All right, review number 3. So solve each equation algebraically. All right, so we're going to go through these. All right, first we're going to have to isolate the absolute value. All right, you got to get the absolute value by itself. So I'm going to subtract 6 from both sides. All right, so this is absolute value. So minus 6, so they're both negative. So you add them, negative 10. Okay, you have to be smart and know that when an absolute value is equal to a negative number, absolute value equal to a negative number, no solution. No solution. All right, that's when it's equal to a negative number. All right, number 2. Let's see. All right, number 2. Negative 9, absolute value of x equals negative 63. So we can't jump to the no solution until we know that just the absolute value is equal to a negative number. So the first thing we're going to do is divide both sides by negative 9. So we're going to get cancels on the left. Absolute value is equal to negative divided by negative. 63 divided by 9 is 7. So absolute value of x is equal to 7. All right, it's just the absolute value, and it's equal to a positive number. So we're good to go to step 2. Step 2 is going to be you separate the absolute value into the positive version and the negative version. All right, so negative 7 and 7, those are the solutions to number 2. All right, number 3. Absolute value is already by itself, and it's equal to 0. So 0, right, if I set this equal to the positive and negative version, there's no such thing as negative 0, right? It's just 0. So when it's equal to 0, we can just drop the absolute value sign. And this is x plus 11 is equal to 0. Subtract 11. X is equal to negative 11. All right, number 4. Absolute value of x minus 1/2 is equal to 2. All right, absolute value is by itself. 2 is positive. So we're good to split this into 2. Drop the absolute value bars and split into 2. So this is x minus 1/2 is equal to positive 2. X minus 1/2 is equal to negative 2. Add 1/2 to both sides. So this is going to be x is equal to 2 and 1/2, which is basically x is equal to 5 over 2. All right. On the right, plus 1/2, plus 1/2. So this is x is equal to negative 1 and 1/2, or 1.5, or x is equal to negative 3 over 2. All right, those are the solutions there. Number 5. Okay, step 1, get the absolute value by itself. So isolate it. So divide both sides by 3. So we're going to get absolute value of x minus 1. And then negative 15 divided by 3 is negative 5. All right, you have to stop and realize that negative 5 is negative. And when that happens, no solution. All right. Only when it's isolated, the absolute value that is. All right. Number 6. Absolute value of x minus 1 minus 1.4 is equal to 6.2. Okay, so there's decimals in this. So we're going to add 1.4 to both sides. So absolute value of x minus 1 is equal to 7.6. All right. So absolute values by itself, the solution is positive. So we're going to split this into 2. So x minus 1 is equal to 7.6. And then x minus 1 is equal to negative 7.6. All right, adding 1 to both sides, we get x is equal to 8.6. On the right, again adding 1 to both sides, we get x is equal to negative 6.6. Right, negative 7 plus 1. All right, those are the solutions. Number 6. All right, number 7. Okay, we have negative 3, absolute value 5x minus 2 is equal to negative 12. All right, we're going to divide both sides by negative 3. Cancels. So 5x minus 2 is equal to positive 4. Absolute value. Our absolute value is by itself. So now we can split this into 2. So 5x minus 2 is equal to 4. 5x minus 2 is equal to negative 4. Right, on the left, we're adding 2 to both sides. So this is 5x is equal to 6. Dividing both sides by 5. So x is equal to 6 over 5. All right, on the right, we're adding 2 to both sides. So 5x is equal to negative 2. Dividing both sides by 5. This is going to be x is equal to negative 2/5. All right, number 8. So the first thing I'm going to do is subtract 4. That's typically the first thing you're going to do. I wouldn't necessarily divide by 5 first. That's actually not correct. Always add or subtract first. So we're going to get 5 absolute value x plus 3 is equal to 19 minus 4, 15. Divide both sides by 5. This is x plus 3 is equal to 15 divided by 5 is 3. Again, absolute value. Okay. Because the absolute value is by itself, the answer is positive. we can split this into 2. So x plus 3 is equal to positive 3. X plus 3 is equal to negative 3. Solving for x, subtract 3 from both sides, x is equal to 0. On the right, subtracting 3 from both sides, we get x is equal negative 3 minus 3. So they're both negative, so you add. And of course it's negative. All right, number 9. Negative 3, absolute value of 2c minus 4 plus 5 equals 17. So the first thing I'm going to do is subtract 5. So negative 3, absolute value 2c minus 4 is equal to 12. Right, 17 minus 5 is 12. Divide both sides by negative 3. We get absolute value 2c minus 4 is equal to negative 4. Right, 12 divided by 3 is 4, and positive divided by negative is negative. All right, you got to be smart, right? Negative 4, it's negative. So no solution. We're almost done. All right, so let's look at this. So solve each inequality and graph the solution. All right. So we're going to treat these the same. The only difference is we have an inequality, but that's the only difference. So we're going to flip the inequality when we divide by a negative, and when we split this into 2, like we did with the equations, the negative version, we flip the sign. So you'll see here in a second. So we got to isolate absolute value of x. I'm going to add 7 to both sides. So this is absolute value of x is less than negative 4 plus 7, positive 3. Okay, splitting this into 2, we get x is less than positive 3, and then x is greater than negative 3. Greater than negative 3. All right, so here you have to remember to flip the negative one. Okay, so x is already by itself. So what we're going to do is we're going to put 2 tick marks, and they get circles. Well, so it's going to be negative 3 and positive 3. Right, you write them in order from left to right. Right, negative infinities to the left, positive infinities to the right. All right, they get open circles because it's strictly less than. Right, these are open circles. And then x is less than 3, so to the left. And then x is greater than negative 3, so to the right. Wait, now that we have our graph, the inequality and interval notation are fairly simple. So when it's shaded in between the circles, you take just the numbers and you put x in between with the appropriate symbol, right? Less than. Strictly less than. And the interval, just the same. Negative 3 to 3. And they both get parentheses because it's an open circle. Right? Parentheses for open circle. All right, and we just Do that again. Okay, number 11. I'm going to subtract 0.7 minus 0.7. So this is going to be absolute value of x minus 3 is less than 2.7. Okay, 2.7 is positive. Absolute value is by itself. So we split this into 2. We get x minus 3 is less than 2.7. Also, x minus 3 is greater than negative 2.7. All right, solving on the left, we add 3. Add 3. X is less than 5.7. On the right, we add 3. Add 3. So x is greater than positive 1.7. Okay. To graph this, we know negative infinity is to the left, positive infinity is to the right. We have 2 tick marks because we have 2 values. I put 1.7 on the left because it's the smaller one, 5.7 on the right because it's the bigger one. And they both get open circles. And we want x less than 5.7, so to the left. And also greater than 1.7. So in between, right? They're in between each other. Inequality 1.7 less than x less than 5.7. For the interval, 1.7 parentheses 5.7 parentheses. Okay. Number 12. All right, here, instincts might tell you divide both sides by 1/3, which is true. You can. But dividing by 1/3 is the same as multiplying by 3. So whenever you have a fraction, if you just multiply by the reciprocal, right, 3/1, but we don't really write the over 1 part. I can do that to both sides, and that'll clear the fraction, right? This cancels on the left. So I get x plus 2, absolute value, less than or equal to 3. All right, 3 is positive, absolute value is by itself. We can split this into 2. So I'm going to get x plus 2 is less than or equal to 3. And then x plus 2 greater than or equal to negative 3. All right, solving on the left, minus 2, x is less than or equal, 3 minus 2 is 1. On the right, minus 2, x is greater than or equal to negative 5, right? They're both negative, so we add, and we keep the negative sign. Okay, to graph this, we know negative infinities to the left, positive infinities to the right. We put them in order. 2 tick marks, negative 5, and 1. Okay, this time, because it's or equals, close circle. Close circle. So we get a colored in close circle. This is going to be x is less than 1, so to the left. And then x is greater than negative 5 to the right. All right, for the inequality, this is going to be -5 less than x less than 1. Interval, just the same. -5, comma 1. And because it's closed circles, they get brackets. Right? We use brackets when it's closed circles. All right, 13. All right, we're subtracting 7. Subtracting 7. This is going to be x minus 2 is going to be greater than or equal to 3 minus 7. So it's going to be -4. All right. So here's one of those situations where you have to be smart and know that this is a negative. Something special has to happen. So unlike the equation, when it's negative, that it's no solution, for the inequality, you're going to have one of two answers. Either it's no solution or it's going to be infinitely many solutions. In this particular case, you have to understand that the absolute value, this must be a positive number. Right? It must be a positive number, no matter what, because absolute values are always positive. So since that's the case, what positive number is greater than a negative number? All positive numbers are. So we have infinitely many solutions. And that's because all positive numbers are greater than a negative number, no matter what. And there's no graph associated with this. It's just infinitely many solutions. I guess. Nah, yeah. We'll leave it at that. You could say all real numbers. That's one way, but it's infinitely many solutions. Okay. 14. We're going to divide both sides by 4. So we get x, absolute value of x minus 6 is less than -8 divided by 4, which is -2. So this is going to be, again, one of those situations. Right, this is negative. So here, you got to think, okay, this is positive. And what positive number is less than a negative number? None. So this is a no solution scenario. Right, because there is no positive number that's less than a negative number. None, not one. So no solution. All right, number 15. We add 3. So this is x minus 5 is greater than 1 plus 3, which is 4. All right, so it's positive. So we can split it into 2. So this is going to be x minus 5 is greater than 4. X minus 5 less than, right, because we have to flip it, less than -4. So if I add 5 to both sides, we get x is greater than 9. Add 5 to both sides. X is less than Negative 4 plus 5 is 1. Okay. To the graph. This is negative infinity, positive infinity, and the 2 tick marks. 1 and 9. This is 1. This is 9. Okay. They both get open circles because it's strictly greater than, right? Open. And then x is greater than 9, so we're going to the right. And then x is less than 1, so to the left. So the inequality, it's going to be 2 pieces. Right? It's going to be 2 pieces. In fact, when it's 2 pieces, our answer are the 2 up here. Right? X less than 1 and x greater than 9. For the interval, it's going to be, so negative infinity up to 1, parentheses, and then 9 to infinity, parentheses. And we union them together. Right, we union them together. The 2 pieces. Okay. We're almost done. We got 3 graphing ones, and then we're done. All right, number 16. Draw the parent function first, draw the transformation, state the domain and range, and describe the transformation. All right, so the parent function is going to be in black. So parent function looks like this. Absolute value of x, 0, 0. That's the parent function. All right, the transformation that they're giving us, it moves the parent function down 1 unit. So goes down 1. Okay, there it is. It just shifted down 1. So the domain is always all real numbers, or negative infinity to infinity. The range is from the y coordinate of the vertex, the new vertex. Right, so the y coordinate is negative 1. Bracket, because it's a closed circle, and it goes up towards infinity. So bracket because it's a closed circle, and negative 1 because that's the y component of the vertex. Describe the transformation. It went down 1 unit. Right, shifted, I guess you could say. Okay. Number 17. So, a couple different things. First off, start with the parent function. All right, there's the parent. And all right, the plus 2 is going to shift up 2 units. The x minus 3 is going to shift it right because the inside lies. And then the negative, it's going to reflect it down or rotate, however you want to look at it. Reflect down. Because right now the parent function is up, so it's going to reflect it down. So we're reflecting down, shifting right 3 and up 2. So 1, 2, 3, 1, 2. So that's the new vertex, right 3 and up 2. And again, it's going down. Instead of going up, it's going down. So the normal down 1 over 1. Down 1 over 1. Domain, all real numbers, right? Negative infinity to infinity every time. Every time. Range, this one's going to start at negative infinity, right? Because it's at the bottom, and goes up to the y part, the y coordinate of the vertex, which is 2, with the bracket. And the description, it's literally what we did. So reflected down, shift right 3, and up 2. Okay, last one. Actually, no, it's not. There's some at the bottom. All right, so 18. We have 3, absolute value of x plus 1 minus 2. So this is going to go down 2. This part left 1. And the 3 is going to stretch the y values by a factor of 3. So think of 3 as like a slope, right? A slope of 3 would be up 3 over 1, right? Up 3 over 1. That's basically what's going to happen, right? Check it out. So if you treat the stretch like a slope, it comes out correct. Watch. So check it out. So here's the original. So the parent function, and then we're going to go down 2 into the left 1. So here's the new vertex. So the stretching part from the new vertex, we're going to go up 3 and over 1, literally in both directions. So check it out. Up 3. So 1, 2, 3 over 1. 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 In both ways. So up 3 to the left 1. 3 to the left, up 3 to the left, up 3 to the left. So there it is. And the stretch can also be thought of as getting narrower, right? It's stretching it this way. So the domain is negative infinity to infinity, always. The range is from the y coordinate of the vertex, so negative 2, bracket, because it's a closed circle, up to infinity. And it's stretched by a factor of 3. Shifted left 1 and right, not right, down 2. All right, so that's graphing. So the last ones are pretty simple. So it's just absolute value, right? The absolute value of a number. Okay, absolute value of 5 is just 5. Absolute value of negative 5 is still just 5. All right, number 21, don't get confused. Absolute value of 5 is 5, and the negative outside is just -5. Right? It's the negative times the absolute value. Number 22, this one's going to be absolute value of -5 is still 5, and negative times 5 is -5. So those are the answers there. All right, good luck on the review. Good luck on the test. Catch you guys in the next video.